Example 1, if f of x equals the square root of x minus 1 and g of x equals x squared minus 4, find the domain of these four things. First one is f plus g. That's the sum of functions. Now, the question doesn't ask me to actually write out what f plus g of x is, but some of the homework questions do, so I'm going to go ahead and do that step too. When you see f plus g, they're actually doing f plus g of x. And if you're just looking at this, you've never seen this before in your entire life, hopefully what you're thinking is that means I take whatever f of x is and add it to whatever g of x is, because that's what it means. It's pretty straightforward. It's pretty, I mean, most people can look at that. That's what you're supposed to do, and that is what you're supposed to do. So, f plus g means take whatever f of x is, which is the square root of x minus 1, add to it whatever g of x is, that's x squared minus 4. I want you to create a habit that anytime you're putting in plus or minus something and you got to put multiple pieces, that you put parentheses around the substitution. So get that habit, but then also recognize when that habit's not necessary. So notice plus x squared minus 4 is the same as plus x squared minus 4, right? But at least go through the thought processes there of do I need parentheses or not? Because the more you do that, the more likely you are to know when parentheses are necessary or when they're not. Okay, in that case, they're not necessary, so we can just avoid the parentheses altogether. That's what f plus g of x looks like. Now our directions say find the domain. Okay, and domain is what it was before. We look at types of functions that are in the problem, and we establish rules based on those functions. There's no rules for x squared minus 4, right? I can square anything, I can subtract anything, so no issues with the. These two terms are behaving themselves very nice, so they're not going to cause any problems. On the other hand, x minus 1 underneath the square root, we know that x minus 1 must be greater than or equal to 0, right? So even though this x squared is just being squared, that's fine. The fact there's a square root in this problem means that to find the domain of this function, I have to find the domain of this piece. So I take the radicand, set it greater than or equal to 0, and I solve x is greater than or equal to 1. So my domain for f plus g equals the set of all x values such that x is greater than or equal to 1. And that's what domain is. So it's what it was before, it's just now we have to create these new functions off of other functions. The second part, f minus g. Okay, so again, using good algebra sense here, I'm going to do f minus g of x. That means I'm supposed to take f of x, which is the square root of x minus 1, subtract from that g of x. Again, surrounding g of x in parentheses, since g of x is multiple pieces. Notice this time, I am subtracting x squared minus 4. The subtraction should distribute, getting me all the way through there like that. So the most simplified version of f minus g of x would be the square root of x minus 1 minus x squared, and then minus minus, so plus 4. Looking at f minus g of x in comparison to f plus g of x, the only thing that changed were this became negative, this became positive, right? It still has the same radical piece in it, right? That same radical piece still has the same domain. These still have no issues, so the domain of this is going to be exactly the same set of all x such that x is greater than or equal to 1. I'm going to use the word usually, but I think I should probably use the word always. But I'm going to say usually just in case there's some weird function out there that somebody out in the world knows about that doesn't do this. But usually, f plus g and f minus g have the same domain. So if you found one, you found them both, basically. I can't think of a single one off the top of my head that wouldn't do that. But again, there's weird stuff out there. Maybe somebody has it. And we'll see. F times g. Fg of x. So f times g simply means take what f of x is, which is the square root of x minus 1, multiply it times what g of x is, that's x squared minus 4. I could multiply the square root of x minus 1 through if I really felt like it, but I don't. I think that's simple enough in my opinion. Notice that the radical is acting like parentheses. If it was like the square root of x and radical then minus 1, I'd want to put parentheses around it, but that bar goes all the way to there, so that treats that whole thing as one term. Once again, g of x in parentheses, because I'd have to multiply this times this piece and that piece to allow that multiplication to actually occur. Notice that this is a polynomial structure. I can put any number into this, right? So the only issue, once again, is the square root of x minus 1. Its domain is still x is greater than or equal to 1. So the domain of this is the set of all x such that x is greater than or equal to 1. I'll use the word usually again. Usually, all three of these domains are exactly the same. Unless there's some weird function out there that I've never seen before that doesn't do that. But usually those are all the same. The final one, f over g. Somebody want to take a guess as to what f over g of x looks like?
Square root of x minus 1 over x squared minus 1.
Perfect. Square root of x minus 1 over x squared minus 4. Now, once again, looking at domain. What happened in this one problem that hasn't happened yet? Division. And can we divide by anything there is? Is there any number out there we're not allowed to divide by? Zero. Okay, so this one thing has given us an extra thing to look at as far as domain is concerned. We still have our square root of x minus 1, which still gets us that x is greater than or equal to 1 look, right? But now we have division. The bottom's not allowed to equal 0, so we have to ask ourselves, x squared minus 4 equals 0. Is that possible? So would everybody agree that x squared equals 4 comes off of that? If x squared equals 4, what does x equal?
2.
What kind of 2?
Plus or minus.
Plus or minus 2, right? So if x equals either positive 2 or negative 2, 2 squared is 4 minus 4 is 0. Negative 2 squared is 4 minus 4 is 0. Either one of those numbers would cause 0 on the bottom. So x is not allowed to equal plus or minus 2, and x must be greater than or equal to 1. So watch how I write this domain. I'm going to leave something off on purpose for a reason. See if you can figure out why. So d equals the set of all x such that x is greater than or equal to 1, comma, x does not equal positive 2. What did I leave off?
Plus or minus.
Okay, why did I leave the plus or minus off? Why am I just taking the positive 2?
Because they're in the thingy.
Absolute value bars?
Yeah.
No.
Because
No, because
it
it's
has to be
squares.
greater than 1,
Because it's
so it
squared.
can never be.
Yeah.
This part here, x greater than or equal to 1, has already taken negative 2 out of the picture, right? If x is greater than or equal to 1, starting at 1 getting bigger, negative 2 is over here, it's already been dismissed because of that. I always want the smallest domain possible. So when you're writing your domains out, if there's some list of numbers, x can't equal these numbers, but they've already been addressed by the other part of it, just give me the other thing. So I don't have to put the plus or minus because negative 2 has already been dismissed. All right, so watch for that. And again, I'm looking for your complete understanding of this idea. So that's the type of stuff that shows me you have complete understanding, that you don't put x does not equal plus or minus 2. Obviously it doesn't. Okay, we follow good algebra to figure that out, but negative 2 has already been taken care of, so we don't have to worry about it anymore when we're listing our domain.